Law of universal gravitation. Objective: to learn Newton's law of universal gravitation and its application. In his law of universal gravitation, physicist Sir Isaac Newton proposed that every object is attracted to every other object with a force directly proportional to the product of the masses of the objects and inversely proportional to the square of the distance between them. Newton's law of gravitation can be expressed in an equation. Fg is equal to g multiplied by m1 multiplied by m2 whole divided by r squared, where Fg is the force of gravity between two objects of mass m1 and m2. R is the distance between the center of the two masses, and g is the gravitational constant. The value of g was determined by scientist Henry Cavendish as g is equal to 6.67 times 10 power minus 11 meter square per kilogram square. The law of universal gravitation implies that the greater the masses m1 and m2, the greater the forces of attraction between them will be. If the mass of one object is doubled, the force will be doubled. If one mass is reduced by half, the force will also be reduced by half. But if both masses are doubled, the force between them will be quadrupled. Similarly, distance and force are inversely related. The greater the distance between the two objects, the weaker the force of attraction. If the distance between two objects is doubled, the force of attraction will be reduced by 1/4. If the distance is halved, the force of attraction will be quadrupled. The attraction between two objects is a consequence of Newton's third law, which states that every action has an equal and opposite reaction. In this case, the gravitational force, Fg, acting on particle m1 is equal and opposite to the gravitational force acting on particle m2 minus Fg. The force of gravity is a vector quantity. Object m1 will attract object m2 with a force directed towards m1. Object m2 attracts object m1 with a force directed towards m2. Let's calculate the force of attraction between the Sun and the Earth. The Sun has a mass of approximately 1.99 into 10 raised to 30 kilograms, while the Earth has a mass of roughly 5.98 into 10 raised to 24 kilograms. The distance between the Sun and the Earth is about 1.50 into 10 raised to 11 meters. If we substitute these numbers into the equation, the force of gravity between the Sun and Earth is 3.52 into 10 raised to 22 newtons, or about 8.0 into 10 raised to 20 pounds of force. Summary: Newton's law of universal gravitation states that every object attracts every other object with a force that is proportional to the product of their masses and inversely proportional to the distance between them.